Hello Algebra 2 class, this is once again Mr. AC. I want to go over maybe a little bit more challenging problem that involves finite differences and gets us a different polynomial degree. So the one thing that I wanted to mention was if you're watching these videos and you're not understanding kind of what we're doing, please come see me after school. We can make a lunch date, come before school or anything, or study hall, so that we can make sure to go over these a little bit more in depth. I'm just kind of going over these videos kind of quickly as more as a supplemental learning. So the second part of this is we have this table. You can go ahead and pause the video and write it down if you need to. I wrote it down ahead of time just to save time. We're going to do the same thing that we did before. We're going to take the difference of our numbers here until we kind of find a pattern, until we find our constant rate of change. So the first thing we're going to do is we're going to have 6 minus 4. Well, that's just 2. Now we're going to have 20 minus 6. We're going to have 20 minus 6, which is, sorry, that's 14. Okay, now we're going to have 76 minus 20. 76 minus 20. So we get 56. Okay, now we're going to have 228 minus 76. Basically 228 minus 76, which is 152. Now we're going to take 554 minus 228, which gives us 326, I believe. Yes. Okay. And now we're going to do 1,156 minus 554, which gives us 602. Okay. Now we notice right away in this moment here that we do not have a constant rate of change. We see these numbers kind of going up. What seems to be like some random number, 2, 14, 56, 152, and it just kind of goes up. It seems like to be sporadically. There's still a certain level of pattern that you could probably find. I'll let you go ahead and do that. But it doesn't really tell us much. So we took our first degree difference and we labeled that as D1. D1 represents first degree difference. Now we're just going to continue doing it until we find a pattern. So we're going to do 14 minus 2, which is 12. And then we're going to do 56 minus 14, which is 42. We're going to do 152 minus 56. 152 minus 56, which is 96. Then we're going to do 326 minus 152, which is 174. And then we're going to get 602 minus 326, which is 276. So before, when we took our when we used this method on the other problem that I showed, when we took our degree difference number 2, we got a constant rate of change. But now in this problem, we still don't have a constant rate of change. So basically what we're going to do is we're just going to continue doing this method until we hopefully reach that point. So now we're going to go ahead and basically repeat the process all over again. We're going to do 42 minus 12. Well, that's 30. We're going to do 96 minus 42, which is 54. Then we're going to do 174 minus 96, which is 78. And then we're going to do 276 minus 174, which is 102. Now we took our degree 3. Our third difference, and we still don't have a pattern. So we need to continue going on until hopefully we see something. So let's just do it again. So we're going to do 54 minus 30, which is 24. We're going to do 78 minus 54, which is 24. We're going to have 102 minus 78, which is 24. Now we took our degree difference. Sorry, I keep saying degree difference, but we took our finite difference to the 4. It took us 4 times. We had to do the finite difference 4 times till we finally got our rate of change that's constant. We noticed that Sorry, I was just looking for another marker to kind of color code it. But we notice now that the rate of change is 24, 24, 24, which is constant. Perfect. At this point, we're done. We know that it took us four finite differences to get to a constant rate of change. So if we know that it took us d4, which is the fourth finite difference, that means that our polynomial is going to be blank degree. And you probably guessed it correctly. So our polynomial is fourth degree. Basically, whatever degree difference you take, it matches. So here it took us 4 times finite difference to get our constant rate of change. So that's d4. So our polynomial is to the 4th degree, and that means then that by definition, degree means that the highest exponent has to be 4. So now our polynomial is going to look like this. We're going to have ax to the 4 plus bx to the 3rd power. Remember, we're just now going to start subtracting 1 from the exponents. So a to the x to the 4th, because it was 4th degree. 4 minus 1 is 3, so that's why the 3 gets there. Then we do plus c x to the 3 minus 1 is 2, plus dx 2 minus 1 is just 1, and then plus e x to the 0. 1 minus 1 is 0. Now if we remember, x to the 0 is just 1, so we can actually just leave it like that. Because x to the 0 is just 1, so we just get e times 1. But e times 1 is just e, because anything times 1 is itself. Okay, so you can either leave it like that. I guess in this video, I'll just leave it like this. And there we go. We have found the equation that will look like a fourth finite difference that we needed to do to take this. And if I remember correctly, this was called a quantic. I spelled that really bad. Let me try that one more time. And if I spelled that wrong, you can go ahead and correct me in the comments because I'm too lazy to check. Hopefully that was helpful in this video.